Hello everyone, in this video let us solve this question together. So we have k raised to power 2k raised to power 6 is equal to 3, and here we have to solve for the value of k. K is the unknown to solve for. To solve this solution, so we have k raised to power 2k raised to power 6 is equal to 3. So from here, we are going to apply a trick, and the trick is this. We are going to say let x equals k raised to power 6. So right here, k raised to power 6, this becomes x. So such that what we have is k raised to power 2 then times x is equal to 3. Now at this junction, let us simplify this. Here we have x equals k raised to power 6, which can be written as k raised to power 6 is equal to x. So from here, let us eliminate power 6 from here by multiplying both sides with power 1 over 6. So in bracket, k raised to power 6 all raised to power 1 over 6 is equal to x raised to power 1 over 6. So with this, what will happen is power 6 will multiply 1 over 6. So 6 will cancel 6, we have power 1. From here, we have k raised to power 1 is equal to x raised to power 1 over 6. K raised to power 1 is k, which equals x raised to power 1 over 6. Now, we've gotten the value of k. So with this, input this value of k into this equation right here. What we have is this. So this becomes, in brackets, k is x raised to power 1 over 6 all raised to power 2x is equal to 3. So from here, we are going to apply this rule that if you have, in brackets, a raised to power b all raised to power c, this equals a raised to power b times c. Applying this rule right here, what will happen is power 1 over 6 will multiply 2x, shows that we have x raised to power 1 times 2x, 2x over 6 is equal to 3. So with this, 2, we divide 6, we have 3. So we have x raised to power x over 3 is equal to 3. Now, at this junction, we are going to cube the both sides of the equation. So we have, in brackets, x raised to power x over 3, then all raised to power 3 is equal to 3 raised to power 3. So applying this rule of indices, that if you have, in brackets, a raised to power b all raised to power c, this equals a raised to power b times c. Applying this rule right here, power x over 3 will multiply 3. So what we have is x raised to power x times 3, 3x over, we have 3 is equal to 3 raised to power 3. So with this, 3, we divide 3, we have x raised to power x is equal to 3 raised to power 3. Now, at this junction, looking at the left-hand side, you will see that the base, which is x right here, the base is equal to the exponent, which is also x. Same thing also on the right hand side. 3, which is the base right here, is also equal to 3, which is the exponent right here. So in such a case like this, in which you have the same base and the same exponent, the same base and the same exponent, what we'll simply do is to simply compare the powers such that x is then equal to 3. Now we've gotten the value of x, but the question is to solve for the value of k. So how do we go about it? But then recall that x equals k raised to power 6, right? So recall that x is equal to k raised to power 6. So we got the value of x as 3. This then becomes x is 3 equals k raised to power 6. Let us then rearrange this. What we have is k raised to power 6 is equal to 3. Now, to solve for the value of k, we need to remove power 6 from here. And to do so, multiply the both sides of the equation with power 1 over 6. This then becomes, in brackets, k raised to power 6 multiplied by power 1 over 6 is equal to 3 raised to power 1 over 6. So with this, applying this rule of indices, that if you have a raised to power b or raised to power c, this equals a raised to power b times c. Applying this rule right here, what will happen is 6 will multiply 1 over 6. So we have k raised to power 6 times 1 is 6 over 6 is equal to 3 raised to power 1 over 6. From here, 6 we divide 6, we have 1. So k raised to power 1 is equal to 3 raised to power 1 over 6. K raised to power 1, the value is k, which equals 3 raised to power 1 over 6. And with this, we've gotten the value of k. But the value of k as 3 raised to power 1 over 6 can still be simplified further by making use of this principle that if you have a raised to power 1 over n, this equals the nth root of a. So applying this rule right here, what you have is this. It can be written as or the sixth root of 3. So the value of k can be written as this also. Good. Now the next thing is to then check, is to verify if this value of k is the correct solution for the given question. So let us check this out. Right here, let us check it out. So check. We got k, which equals the sixth root of 3, or k is equal to 3 raised to power 1 over 6. And the given question is k raised to power 2k raised to power 6 is equal to 3. So therefore, inputting the value of k into this equation, let's input the value of k as this. So k becomes, in bracket, 3 raised to power 1 over 6, all raised to power 2 times k is 3 raised to power 1 over 6, then all raised to power 6, with this equal 3 question mark. So from here, we have, in bracket, 3 raised to power 1 over 6 multiplied by power 2. Now 1 over 6 will multiply 6. So therefore, 6 will divide 6. We have 3 raised to power 1, which is still the same thing as 3 is equal to 3. With this equal question mark. From here, what we have is, in bracket, 3 raised to power 1 over 6, all raised to power 2 times 3 is 6, which equals 3. With this equal question mark. Also, from here, 1 over 6 will multiply 6 such that 6 will divide 6. What we have is 3 raised to power 1 is equal to 3. And with this, 3 raised to power 1, the value is 3, which equals 3. Now, since they're equal to each other, this means that the value of k that we got, right, as 3 raised to power 1 over 6 is the correct solution for the given question. So with this, I hope you all enjoyed the video. Don't forget to like this video, subscribe to this channel. Thanks for watching. See you in the next video. Bye.